This video demonstrates how to find the slope of a tangent line to a curve at a point. So this is the point, and we have to find the slope of this tangent line at this point. But you have learned how to find the slope of a line when the coordinates of 2 points are given. So if the 2 points are given, we know how to find the slope of a line like this. If the 2 points are given, then we can find the slope by using the formula, which is y2 minus y1 over x2 minus x1, or change of y over change of x, or in some books they say rise over run. You have learned this in algebra 1 and some part in algebra 2. It seems challenging to find the slope of a line when a single point on the graph is given. Now we have only one point, not the 2 points. So it seems if it was 2 points, we could have seen we can find the slope by using rise over run. But in this case, we have only 1 point. So as I said, it seems challenging to find the slope of a line when a single point on the graph is given. Now, in calculus, which is known as the mathematics of motion, a secant line is created by having an additional point on the graph like this. So there is a point created which is h unit away from the given point. So there is, I created another point which is point Q, which is h unit away from the given point x. So the coordinate of the new point is going to be x plus h, because it is h unit away from the given point, which is x, and the y value is going to be f of x plus h. So now we have 2 points and we can find the slope of this line. But this line is not the tangent line, it is a secant line. And but we can find the slope of this line by using the formula, and we can write now. We can find the slope of this line is going to be, the slope m is going to be y2, which is f of x plus h, minus y1, let us say f of x is y1, divided by x2 minus x1, which is x plus h minus x. So this slope, we can rewrite this becomes f of x plus h minus f of x over this positive x and negative x give us h. So the slope of the secant line is given by this formula, which is same as what we have done in algebra 1, y2 minus y1 over x2 minus x1. So now we are going to move this. You see that the h value is 3.9 here. So what happens if the tangent line is the red line? What happens if this new point, which is point Q, as is this point, moves towards the given point, which is P, then the green line, which is the secant line, becomes the tangent line. The green line becomes the tangent line. And this is what the approach we are going to use. So we have created this new additional point, and then what we did, we moved the point which is like this one, and then we moved it. Now we are going to discuss the secant line. Like one more time, I'm going to show you that the create a point on the graph which is x plus h unit away from the given point, and that is the point. Then we created the secant line, and then the secant line, as the h is moving towards the original or the given point, then it becomes the tangent line. The secant line becomes a tangent line when the additional point is approaching the given point. This is how the definition of the first derivative is derived. So let us move this point, h point. As you can see, the value of h is reducing, and when it becomes 0, then the secant line becomes the tangent line, and the definition of the first derivative which is given here. So this is how the definition of the first derivative is derived, and we find the first derivative using this definition. I hope you understand the visual demonstration of the secant line becoming a tangent line, and how to find the definition of the first derivative.